So for this video, we'll be showing some examples of the GCF, or the greatest common factor. So we start with which of the following is not a factor of 100. For this one, there are many ways that we could go on with this example, but we'll start off by listing the factors of 100. So for the factors of 100, we have 1, 2, 4, 5, 10, 20, 25, 50, and 100. Now let us check which among the given does not include in this set of factors. So for 5, clearly 5 is over here, so we circle that, we cross that out. For 20, 20 is also here, so we cross that out, since we are asked which among is not a factor. For 8, clearly 8 is not in this set, so this must be the answer. But let's also check 100. But note that 100 is a factor, and in fact, a number is always a factor of itself. So we cross that out. So we have found that 8 is not a factor of 100. For this example, we are tasked to find which of the following is a common factor of 16 and 20. So let's try to list the factors of 16 and 20. So we have here 1, 2, 4, 8, and 16. For this one, we have 1, 2, 4, 5, 10, and 20. Now let's check. Clearly, the common factors of 16 and 20 are only 1, 2, and 4. So 8 is not a common factor of 16 and 20. 1 is a common factor of 16 and 20. 10 is not, since both 8 and 10 are only factors of either 16 or 20. And the same goes with 5. So we have found that the answer for this problem is 1. And in fact, note that 1 is always a common factor among any given numbers. For this example, we are tasked to find the GCF of 80 and 100. For this one, let's try applying the factor tree method. So let's write out 80 and 100. For 80, since it ends in 0, we know that it is divisible by 10. So we write 8 and 10 out here. Now this one, we know that this decomposes into 2 and 5. And this one is 4 and 2. 4 can still be factored as 2 and 2. For 100, we have 10 and 10, since 10 squared is 100. Now like in here, we know that 10 when factored would give us 2, 5, 2, and 5. So with that, let's move this first out of the way. And now let's express 80 and 100 in its prime factors. So for 80, we have 2 raised to 4 times 5. For 100, we have 2 squared times 5 squared. Now note that in getting the GCF given the prime factors, what we get is the one with the lower exponent. So for this case, it's 2 squared and 5, since this one is 5 raised to 1. So we have the GCF of 80 and 100 to be equal to 2 squared times 5, or 4 times 5, which is 20. Let's go on to our fourth example. In here, we are tasked to find the GCF of 125 and 250. For this example, let's apply again the factor 3 method. So we have 125 and 250. So for 125, we can factor this out as 5 and 25, wherein 25 is simply 5 and 5, since 25 is equal to 5 squared. For 250, since it ends in 0, we can factor this out as 25 and 10, which would give us 5 and 5, as well as 2 and 5. So let's move these out, and let us again express these two numbers in terms of its prime factors. So we have 125 is equal to 5 cubed. On the other hand, 250 is equal to 2 times 5 cubed. Now let us compare again. First, for the 2, note that although it's not written here, in 125, there is 2 raised to 0 out here, since 2 raised to 0 is equal to 1. So that one is the lower exponent. For 5, since they are both 5 cubed, we just circle one of them out. So we now know that the GCF of 125 and 250 is equal to 5 cubed, or 125. Observe that 125 is actually one of the numbers, and that is possible when one of the numbers is a factor of the other number. In this case, 125 is in fact a factor of 250, since 125 times 2 is 250. Let's go on to our fifth example. For this one, let's try to apply the continuous division method. So let's write 68, 88, and 242. First, note that all of these numbers are divisible by 2, since all of them are even. So we write 2 out here, and that would give us 33, 44, and 121. Now for this one, note that all of them has a factor of 11. Indeed, 33 is equal to 3 times 11, 4 is equal to 4 times 11, and 121 is 11 squared, or 11 times 11. So we write 11 out here, which would give us 3, 4, and 11. Now for our bottom numbers, since there are no more common factors among them except 1, this would become our GCF. or simply 2 times 11 is 22. For our final example, let's try to work on a harder example. So for this case, we try to find the GCF of 12a squared b cubed and 15a cubed b raised to 4, provided that a and b are integers and there are no common factors between 4 and their product. So let's try solving this one. So let's try to apply the continuous division method again. So we are setting up now the numbers. So first, we know that 3 is a common factor of both of these numbers, since 3 is a common factor of 12 and 15. So that would give us 4a squared b cubed and 5a cubed b raised to 4. For this one, note that a cubed is equal to a squared times a. That means that we can factor out a squared out here. So that would give us 4b cubed and 5a, and that would give us 5a b raised to 4. Also, observe that b raised to 4 is equal to b cubed times b, which means that we can factor out b cubed in this, and that would give us 4 and 5ab. Now, are we done? Well, in fact, yes. But note that if 5ab has a factor of 4, then we can still factor 4 out here. But since it is given out here that there are no common factors between 4 and their product is actually ab, which means that the LCM is this one. So the LCM is given by 3a squared b cubed, and that is our final answer. So in these problems, although we experience the use of variables, we see that with the same principles in real numbers, we are able to obtain the LCM of the given. So that is all for this video.